His theories and ideas laid the groundwork for the digital revolution. From wartime cryptography to the modern cell phone, from electromechanical relays to the internet, his ideas made them all possible. Meet Claude Shannon, the father of information theory and a hero of the digital revolution. In the 1940s, Claude Shannon, a young research mathematician at AT&T's Bell Labs, was looking for a way to transmit communications more efficiently. At the time, telecommunications consisted of telegraphs, radios, telephones, and for a lucky few, the television. But they all had a common denominator: information. What Shannon realized was he could take any type of information and quantify it by assigning a source rate measured in bits per second. Shannon introduced his idea to the world in his 1948 paper, The Mathematical Theory of Communication. It set the engineering world on end.
His theory on communications, it just radically changed how people thought of how communications over wires, telephony at the time, occurred. It changed it from thinking that in order to get highly reliable communications, you had to slow the communications down, which, as we know today, with fiber optics and high-speed wireless, etc., would be a disaster. We wouldn't be doing it.
But according to Shannon, there were limits.
The realization by Claude Shannon that there's a relationship between channel bandwidth, power, noise, in order to determine how fast a transmission can communicate information, suggested that what you want to do is design with a consciousness of the Shannon limit, which simply says, how fast can I go given this amount of power?
You wouldn't have to transmit speech in a waveform. You'd sample it and convert it to bits, zeros and ones, and send the zeros and ones down a wire, and at the receiving end, you would take these zeros and ones and build back a replica of the original signal.
The impact of information theory is all around us and continues to influence important research today.
I would say if you looked at AT&T Labs today, you would find it difficult to find things that aren't, in some sense, a result of Shannon's theories.
Though his landmark paper was published in 1948, Shannon began making his mark a decade earlier as an MIT researcher and student. His master's thesis, a symbolic analysis of relay and switching circuits, has been hailed as the most important thesis of all time. Using and, or, and not logic, Shannon demonstrated how to combine Boolean algebra with binary arithmetic and apply it to electromechanical switching.
Relays in particular were relevant because they were used in telephony. AT&T had many relays because that's how telephones were controlled.
Because of Shannon's work, Boolean arithmetic is the basis for the design and operation of every computer in the world. While the bulk of his work encouraged communications, Shannon also devised ways to prevent some communications from ever taking place.
Claude Shannon was the first one really to make the connection between security and information theory. He saw them as intertwined. So when he wrote his paper, his landmark paper, Mathematical Theory of Cryptography, that was really an amazing contribution.
Not one to rest on his laurels, Shannon published yet another landmark paper in 1949, Programming a Computer for Playing Chess. A year later, he entered the field of artificial intelligence with his mouse, Theseus.
I'm Claude Shannon, a mathematician here at the Bell Telephone Laboratories. This is Theseus. Theseus is an electrically controlled mouse. He has the ability to solve a certain class of problems by trial and error means and then remember the solution. In other words, he can learn from experience. Like his classical namesake, Theseus has the problem of finding his way through a maze. His objective is the goal here in the corner. He is now exploring the maze using a rather involved strategy of trial and error. As he finds the correct path, he registers the information in his memory. Later, I can put him down in any part of the maze that he's already explored, and he'll be able to go directly to the goal without making a single false turn.
His brilliant ideas did not stop there. On his desk, he kept a box he called the Ultimate Machine.
It's an amazing machine. It's a box, it's a wooden box, and it's totally featureless except for a single switch. So you throw the switch, and a lid opens up, and an arm comes out of the box, a mechanical arm. It looks like a real hand, and it turns off the switch, and the arm goes back into the box, and the lid closes. And that's it.
You know, there's a playfulness in great researchers that you see all the time. Sometimes we would see it as a little quirky. In Shannon, you saw it in all of his little hobbies and interests, building a mechanical mouse and building a juggling machine and riding his unicycle around the labs always. It's one of the more charming elements that we all remember when we think about Claude Shannon.
Shannon left AT&T in 1956 with his bride Betty, a Bell Labs numerical analyst, to teach at MIT, and retired in 1978 to pursue his other passions. They included juggling and building gadgets like a gasoline-powered pogo stick, a robot that could solve Rubik's Cube, and his throwback machine, a computer that calculates in Roman numerals. His awards include the National Medal of Science, Japan's Kyoto Prize, and the IEEE Medal of Honor. He's a fellow at AT&T, MIT, UCSD, Princeton, and IBM, to name just a few. But perhaps his biggest honor is in Florham Park, New Jersey.
I think everybody here is really proud that the research labs here are named after Shannon. It's hard to think of anybody who had more influence on the kinds of things we do here. And it's hard to think, frankly, about what kinds of things we would be doing had he not done the things he did.
Shannon reflects on his life's work in information theory.
I didn't think in the first stages that it was going to have a great deal of impact. I enjoyed working on this kind of a problem, as I have enjoyed working on many other problems without any notion of either financial or gain in the sense of being famous and so on. And I think, indeed, that most scientists are oriented that way, that they are working because they like the game.
Dr. Claude Shannon was a scientist, engineer, founding member of the Unicycling Society of America, and the father of the information age. But his passing in 2001 did not leave a gaping hole in the world of mathematics and engineering. Instead, it left an open door, a door to creativity, innovation, and the possible. And that is why Claude Shannon is not only a tech icon, but a hero of the digital revolution.